Am I audible?
Yes, you are audible.
Is my screen visible?
Yes, ma'am.
Okay. Good day, everyone. Myself, Diksha Bhatt, teacher trainee from Nirmala Institute of Education. Today I will be taking science class. Few instructions before starting with the class. If I'm not audible or if my screen is not visible, then unmute yourself and let me know. I hope you all could hear me till now.
Yes.
So let us begin with the class. Here on screen you can see some pictures. Now I want you all to classify them into two groups based on some characteristics.
Well, here some objects are moving and some are at the rest.
Yes, correct. So some objects are moving and some objects are at rest. Here we have a table and there I have kept a book on it. A and B are 2 points on the table. Now observe this book carefully. What did you observe?
That the
A
book
book.
is pushed from point A to point B.
Very good. We also observed that book took some time to move. Now look at this image carefully. What did you observe?
A man is pushing the car.
Yes, correct. Therefore, to move a car from its state of rest, large force must be applied on it. Hence, the car must be pushed hard so that it should move from its original position. Now I want someone else to answer. What is this person doing? What is this person doing?
Pushing a shopping cart.
Yes, correct. So in the previous classes, you all have learnt about motion and types of motions. Now define motion in your own words. I want everyone to answer this.
Movement.
Yes, correct. Sneha, would you like to answer?
Motion is movement which may have some direction.
Yes, correct. So any object that moves over a time is said to be in motion. You can see on screen a man is trying to push a wall. He applies all the force. He gets exhausted and stops doing that. What did you observe about the position of the wall?
It is the same. It did not change.
Yes, correct.
There's no change in
Now,
the position.
yes, very good. Now tell me, among book, trolley and wall, which one has highest mass? Among book, trolley and wall, which one has highest mass?
Wall.
Well,
Yes, wall has highest mass. The mass of a book and trolley is less, hence less force is required to move them. Whereas mass of a wall is large, hence large force is required to push a wall. So in which out of these three situations do you think we have done some amount of work? I repeat, In which of these situations do you think we have done some amount of work?
Movement of book.
Yes.
And in case of the trolley.
Okay, correct. So all these illustrations are closely related to each other. They all are related to work done or no work done. So today we are going to learn about work in our topic work and energy. As you all said, a push or pull which tries to change or changes the state of rest of a book is called force. Let's take one example. You can see a boy is trying to push a car. That is, a boy is trying to change the state of rest of the car. Now let us take one more example. Here you can see a girl trying to pull her trolley bag. It means she is applying force in order to move a bag and she is changing the state of motion of a trolley bag. We see that as a girl is pulling a trolley bag, the position of a trolley bag changes every time. From this we can say that the trolley bag is moving from point B to point A. So from these two examples, what did you observe?
That one has to push or pull in order to move something.
Yes. So in these examples, object was at rest, force was applied, and the object was displaced from its original position. Now look at this image carefully. This is the wooden block. What did you observe?
Man pushing a wooden block.
Yes, correct. A man is pushing a wooden block. So in science, we define work as work is said to be done if a force acts on an object and an object must be displaced. Now look at this image. Here, boy is trying to push a big rock. Is he applying force?
Yes.
Yes, correct. Is the object, that is rock, which is trying to push, is being displaced?
No.
Okay. Now in the second case, a boy is trying to push a wall. So what did you observe about the position of the wall?
It is stagnant, not moving.
Yes. In this case, is the person trying to apply force?
Yes.
Yes, correct. So in these cases, what do you observe? So in both of these cases, we observed that force was applied, but there was no change in the position of an object. That is, object was not displaced. Therefore, we say that in these cases, no work was done. Suppose Ria had two boxes loaded with 20 and 30 books respectively. She wants to place these boxes into another room. So she tied the string to the boxes and pulled them one by one from the certain distance. After lifting which box, after lifting which box, she would feel more work was done.
Box with 30 books.
Yes, correct. So we know that to pull, push, and to lift the greater weights, we apply greater force. Here we saw that Ria had to apply more force when she pulled the box with 30 books for some displacement. From this we say that more work is done for same displacement when more force is applied to perform a work. And if same force is applied for some displacement, for more displacement, then more work is done by the force. Now look at this picture on the screen. Let us perform one small activity. A boy is standing on one end of the cupboard and applies a force on the cupboard. Now he is applying a force on the cupboard. You will find that cupboard moves or it is displaced from its original position. Now can you tell me the direction of force and direction of displacement, are they same? That is the direction in which you are applying the force. Is it the same in which it is getting displaced?
Yes.
Yes.
Yes. In this case, the direction of force is in forward direction as you are applying the force, and you will find and you will find as you are applying force on the cupboard, the direction of displacement is also in the forward direction. So in this case, when you are applying force in the forward direction, it is getting displaced in the forward direction. So over here, direction of force and direction of displacement are same. Now let us take another example. Over here, a girl is carrying a trolley bag. As you can see on the screen, when she is moving a trolley bag, she has to apply force. Where she has to apply force? Am I audible? Hello?
Yes, you are audible.
Okay, so in this image, a girl is carrying a trolley bag. Okay, while moving a trolley bag, she has to apply a force. So where she is applying a force in order to move that trolley bag?
On the handle of the bag.
Yes, correct. So she has to apply a force on the handle of a trolley bag. As you can see in the picture, the force is being applied in this direction. But in which direction is trolley moving?
In the forward direction.
Yes, but trolley is moving in the forward direction. So tell me, in this case, the direction of force and direction of displacement, are they same?
No.
Yes. So by these two examples, we conclude that the direction of force and direction of displacement are not always same. Okay. Now consider this wooden block as an object. Let a constant force F act on this object. Let A be the initial position of this object. As the force acts on an object, it gets displaced through the distance s. Let W be the work done. We define work done to be the product of force and displacement. That is, work done is equal to force multiplied by displacement. We write it as W is equal to F multiplied by S. Work done by a force acting on an object is equal to the magnitude of the force multiplied by the distance moved in the direction of force. Now let us revise some units. What is the unit of force?
Newton.
Yes, correct. What is the unit of distance? Am I audible?
Yes.
I want someone else to answer. What is the unit of distance?
Kilometers.
The unit of distance is meters. Okay. So what will be the unit of work? Yes, this is the formula for the work done. Now, in order to find the unit for work done, we have to multiply the unit of force to unit of displacement. Now, what is the unit of force? Just now we saw. What is the unit of force?
Newton.
Yes, and what is the unit of displacement?
Meter.
So, what will be the unit of work done?
Newton meters.
Yes, correct. The unit of work done is Newton meters. Joules is also a unit of work done. Now, using above formula of work, let us define 1 joule of a work done. 1 joule of a work is said to be done when 1 newton of a force acting on an object displaces it 1 meter in the direction of the force. You can just see this formula. Work done is equal to force multiplied by displacement. So 1 joule of work is said to be done when 1 newton of the force acting on an object displaces it 1 meter in the direction of force. Now let us solve some problems. A boy is trying to push a wall. He applies a force of 20 newton in order to push a wall. What will be the displacement in this case?
Zero.
Why 0?
Because the wall doesn't move.
Yes, correct. So the displacement will be 0. So what are we told to find now? Work done. We have to find what is the total amount of work done. So what is the formula for the work done?
Force into displacement.
Yes. So what will be the next step?
To substitute the values.
Yes. So after substituting the values, what we will get?
0 is the answer.
Zero.
Yes. Let's go step by step. Let us substitute these values. We will get 20 multiplied by 0. So the answer will be 0. So work done in this case is 0. So if object is not displaced, then no work is said to be done. Similarly, now you all tell me, what will be the total work done if force acting on an object is equal to 0? Okay, let's go step by step. So we are told to find the total work done. So what is the formula for the work done?
Force into
Work.
displacement.
Yes, correct. What are we given?
Force.
Yes, we are given the value of force. Now let us substitute this value. We will get work done is equal to 0 multiplied by S. So what is the answer to this?
Zero.
0. So if there is no force acting on an object, then no work is said to be done. So now we have seen two cases wherein work done is equal to 0. Which is the first one? The first case is when the object is not displaced. And the second case is when no force is acting on an object. Now let us solve some problems. I want any one of you to read this question.
A force of 10 Newton acts on an object. The object gets displaced through 2 meters in the direction of force. Calculate the work done.
Thank you. Okay, so what are we given?
The force
10
applied
Newton.
and the distance in which it is displaced.
Yes, correct. And what are we told to find?
Work done.
Work done.
Yes. So what is the formula for the work done?
Force into displacement.
Yes, correct. Work done is equal to force multiplied by displacement. So what will be the next step?
Substituting the values.
Correct. After substituting the values, what you will get?
10 Newton into 2 meter is equals to 20.
Yes. So work done is equal to 10 multiplied by 20. 10 multiplied by 2. So what is the answer?
It is
20 joules.
20 what? Yes,
20
correct.
joules.
20 joules or 20 Newton meters. Let us solve one more problem. I want someone else to read this question.
A force of 7 Newton acts on an object and the object gets displaced through 1 meter in the direction of force. Calculate the work done.
Yes, thank you. Okay, so what are we given here? What is given in the question?
A force acts on
The
an
force
object that is 7 Newton.
Yes,
and the object gets displaced through 1 meter.
yes, correct. So we are given the value of force and displacement, and we are told to find the work done. So what is the formula for the work done?
Force into displacement.
Correct. Work done is equal to force multiplied by displacement. So let us substitute these values. We will get 7 multiplied by 1. What is the answer?
7 Newton meter.
Yes, 7 joules or 7 Newton meters. Now let us watch the summary video.
Hello everyone. Imagine you are trying to push a big iron ball. You're giving your best, but it doesn't even move an inch. So, you applied lots of force, but unfortunately, no work is done. Then, a muscular guy comes and pushes the ball and it moves. So, the force didn't go waste this time. It did some work. And this is because, according to science, work done is equal to force multiplied by displacement. So always remember that two conditions need to be fulfilled for work to be done. Number one, a force should act on an object, and number two, the object must be displaced. So, if any one of these conditions does not exist, work is not done. Suppose you are pushing a wall. You apply a lot of force, still the wall does not move. So, there is no work done. Well, as the wall hasn't moved or displaced, we say here the work done is zero. Now, if we apply 1 Newton force on an object to make 1 meter displacement, then that is force denoted by F is equal to 1 Newton and displacement denoted by S is equal to 1 meter. Then the work done by the force will be 1 Newton meter. Newton meter is also called joule, so we say work done will be equal to 1 joule.
That was all for today. So in today's class, we learnt about work done, units of force, displacement and work done. We also saw the conditions in which no work is done, and we solved some problems based on the formula for the work done. Now let's see how much you all have understood. Select the most appropriate alternative. Work is said to be done if force acts on an object gets displaced, force acts on an object and object is displaced.
Option 3, teacher. Force acts on an object and object is displaced.
Let's check. Yes, correct. What will be the work done if no force acts on an object? Work done is equal to 100 joules. Work done is equal to 0 joules. Work done is equal to negative 100 joules. Work done is equal to 50 joules.
Second option.
Option second.
Let's check.
Work done is equal to 0 joules.
Yes, correct. And what is the other condition wherein the work done is equal to 0?
And there is no displacement.
Yes, correct. Select the formula for the work done. Work done is equal to force multiplied by distance. Work done is equal to force multiplied by displacement. Work done is equal to force multiplied by speed. And work done is equal to force multiplied by time.
Option second. Work done is equal to force multiplied by displacement.
Let's check. Yes, correct. Now match the pairs. Over here you have the quantities and on the other side you have the units. What is the unit of force?
Newton.
Let's check. Yes, correct. What is the unit of displacement?
Meter.
Very good. And what is the unit of work done?
Two of them, Newton meter or joule.
Yes, Newton meter and joule. Correct. Now define 1 joule of work. Okay, tell me the formula for the work done. What is the formula?
Work done is equal to
Yes.
force multiplied by displacement.
Yes.
When the force and displacement is 1.
Yes, correct. So we say it as 1 joule of a work is said to be done when 1 Newton of a force acting on an object displaces it 1 meter in the direction of force. Okay. Now let us solve one problem. A force of 10 Newton is acting on an object and the object gets displaced through 10 meters in the direction of force. So calculate the work done. So what are we told to find?
Work done.
Okay, so what is the formula?
Work done is equal to force multiplied by displacement.
Very good. So what is the next step?
Ten Newton multiplied by 10 meter.
Yes, we have to substitute the values. So we will get 10 multiplied by 10. What is the answer?
100.
100 joules or 100 Newton meters. Okay. So for homework, list out some activities or examples of a work done from daily life. Thank you for attending the meeting. You all may leave the meeting now.
Thank you, teacher.
Thank you.